Hello, it's me again. Okay, so I just realised that we did miss out a couple of questions on the projectiles in this booklet, so I just thought it would be a good opportunity to go over that one. We might as well. Okay, so remember, projectile motion is in the vertical plane with constant acceleration. So the acceleration is down to gravity and it only acts in the vertical direction. Okay, so you can use it, you can analyse it using vector equations of motion. Now, when we looked at projectiles, we kind of looked at the horizontal, we looked at the vertical, but we can do it all in one by just considering I and J, okay, like we have been doing in the rest of this booklet, okay. So this example here says a ball is struck by a racket from a point A which has a position vector of 20 j metres, so 20 metres up, relative to a fixed origin O. Immediately after being struck, the ball has a velocity of 5I plus 8j. So 5I plus 8j is your initial velocity, if you think about it and you see that equation. Okay, I and j are the unit vectors horizontally and vertically. After being struck, the ball travels freely under gravity. So if we think about freely under gravity, the only thing that it's affecting is gravity is, in this case, because it's being projected up, is going to slow down. Okay, so as it slows, so it'll slow down obviously due to gravity, so 9.8, so it'll be minus 9.8, but in the j direction, and obviously there's no acceleration in the I direction, it's travelling at a constant velocity, so it's 0I. I've just included it for completeness, okay? The first question then it says it strikes the ground at point B, so obviously B is going to be 20 metres below that striking point A. The first part of this question then says find the speed of the ball. So obviously if we want the speed of the ball, the first thing we need to find is what the velocity is. Okay, so if we look at the information we've now got, and I've put that down for you, hopefully you can see that we need to use V equals U plus AT. Okay, so we've got V equals 5I plus 8J plus 1.5 times 0I minus 9.8j. So in this case, it's going to be 5I, and then in the j direction, it's going to be 8j minus 14.7j. So we've got 5I minus 6.7j. Okay, so that is its final velocity, or its velocity I should say, 1.5 seconds after being struck. So now if we want the speed is the magnitude of the velocity, so it's going to be the square root of 5 squared plus 6.7 squared. Just let me get you the answer. So we know where we're going. Okay, so it'll give us 8.36 metres per second. Okay. Right. Hopefully that makes sense. Okay. So now the question says find an expression for the position vector r of the ball relative to O at time t seconds. Okay. So what we need to do here is we need to think about the position where it'll be at any point here. Okay, so because it's asked us about position, we know we want to find S. Okay, now once we've found an expression for S, or how far it will have travelled, then what we need to do is we need to take into account where it started from. Okay, so we want to find S. We know U was 5I plus 8j. We know the acceleration is 0I minus 9.8j, and we want to find the time at t seconds. Okay, so using the equation now, we can see it's S equals ut plus a half at squared. So you've got t times 5I plus 8j, okay, plus a half t squared, 0I minus 9.8j, okay. If I just try to make that look a little bit nicer, I've got, in the I direction, I've just got 5ti, okay, because obviously half t squared times 0 is going to disappear. And then in the j direction, I've got 8t and it's going to be minus 4.9 t squared j. Okay, so that is its displacement from where it started at the time t seconds. Okay, so if I now want to know it's the position of it, I need to take into account where it started. So its position will be where it started at A plus its position relative to A plus where A is, which we know is 20 metres up, so plus 20j. So just adding that in now, that takes us to S equals 5ti plus 8t minus 4.9t squared plus 20j. Okay, just adding that 20j on. Alright, so that's an expression for the position vector at time t seconds. So now part C says, hence determine the distance for B. Okay, so if we use our answer from part B now, okay, we know that the distance O to B is when the vertical, sorry, just let me move the diagram, is when the vertical height, so the J component of the displacement is 0, okay? And what we want to find is we want to find what the horizontal displacement is x, or the I component of the displacement. So what I want to find is I want to find what S is in terms of xi, but I know that the j component will be 0. So what I can now do is, because this is a position vector, I can substitute that in to my equation, okay? And if I look at, or compare it, sorry, to my equation, and if I look at this now, can you see x must be equal to whatever 5t is, okay? But I also know that because it's got a vertical displacement of 0, 0 must be equal to this here, okay? So that helps us solve a quadratic equation now. So you've got minus 4.9t squared plus 8t plus 20 equals 0. That's going to give me 4.9t squared minus 8t minus 20 equals 0. And I have not got my fancy calculator on me, so just bear with me a minute. Sorry. So we should get from that t equals 2.9953, and the other value you would get, it will be a negative, I'm assuming, but you should just write it for completeness, is minus 1.36, which obviously doesn't make any sense in this question. Alright, so now we can use the fact that we know that t is 2.99, okay, and if, like I said before, if we compare the I components, we know that x has to be equal to 5t. So x equals 5t, so x is 5 times 2.9953, or whatever's in your calculator. And it tells us that the x distance now has to be 14.9765, okay, or 15.0 meters to 3 significant figures, okay? All right, so that's just the way that we can do it if all the information is in I and J, okay? On the next 2 pages then here, there are 2 questions. So there's a question that's quite similar, there's just an unknown variable p in it, and then there's a question here, which I did want to go through reviewing in class, okay, where you've got to show that an equation is written in this form. Now I might just go through that with you actually now, okay? So in this question, it says use g equals 10. So it says a body B is projected from a fixed point O on horizontal ground with a velocity of ai plus bj meters second. Okay, so on our suvat, we know it's AI plus B in the J direction. Okay, it says the body moves freely under gravity, so freely under gravity, so we know it's 0I minus 9.8J. Okay, until it hits the ground at the point P, where it immediately comes to rest. Okay, so it says the position vector of a point on the path relative to O is xi plus yj. So we know that S is xi plus yj. And it says show that y equals bx over a minus 5x squared over a squared. Okay, so the only thing that we can use now really is the time, and we don't know the time. All right, so what we can do now is come up with an equation in terms of I and j. All right, so if we look, we've got s equals ut plus a half at squared. So this is xi plus yj equals ai plus bj times t plus a half, let me move this across, t squared 0i minus 9.8j. Okay, so if we just try and make that look a little bit nicer now, you've got xi plus yj is equal to at in the I direction, and then in the j direction you've got b times t minus half of 9.8, so minus 4.9. Oh, sorry, g is 5, so minus, ignore that. So that should be 10j because it said that g was 10, so that should be bt minus 5t squared j. Okay, so if we look now, can you see we can write x is equal to at, and we can write that y is equal to bt minus 5t squared. So that just comes from looking at our I components, that just comes from looking at our j's. Now obviously here, the t value has got to be the same, okay? So if we rearrange this, we've got t would be equal to x over a, and all we need to do then now is substitute that x over a into this expression. So we've got y equals b times x over a minus 5 times x over a all squared, which gives us, hopefully what we need, bx over a minus 5x squared over a squared, which is exactly what we want. Okay. So now part B, I'm going to leave you to try on your own. So it says, given that A is 8, so it tells you 8, the OP is X, and the maximum vertical height of B above the ground is Y. So if you think about it, the maximum vertical height above the ground is when the velocity in the Y direction is equal to 0. So you can use that to help you. Alright, I will do my full solution and I'll post a picture of it online, but I just wanted to help you get that equation. Alright, hope that helps. Thank you.